Statistics, here we go. We're going to do section 3.7 today on designing an experiment. Now, an observational study is when you don't apply any kind of a treatment. An experiment is where you do apply a treatment. And here are ways to appropriately design an experiment in statistics. There are three principles. Three principles of experimental design that help us ensure that we get legit information. The first one is control, a control group we've already talked about. The second one is random assignment. Now once I get my sample, which I already used random sampling, misspelled some, shouldn't talk and write at the same time. Once I use some kind of a random process to get a simple random sample or whatever, then I'm also going to use another random process to put them in experimental groups. And the third one is called replication, and that'll make sense when we get to it. Okay, you've already learned about the control group. Principle of experimental design number one. The purpose, we use a control group so we can compare our results with baseline data. What was life like without the treatment, and now what was life like with the treatment? Basically, the control group gives us something to compare to. The second principle is random assignment. Now again, to get your group in the first place, your sampling design probably has some kind of a random way of picking your sample, but now we're randomly assigning them into groups. We use a random assignment and attempt to make the treatment groups as equivalent as possible. That way, any difference in the measurements after the treatment's been applied, it won't be due to some outside variable. And remember, we're terrible at randomly assigning things, right? We overthink it and we put some order when we shouldn't. So let random assignment put people in groups, and we're more likely to have equivalent groups, so that if you see a difference, it's because of the treatment, not because of how we put them in groups. The third principle is replication, and we'll get to that in another page or two toward the end of the show here. Okay, so book example, I'm going to go to page 222 from the previous section, 3.6. I'm going to read a bad experiment in the middle of that page. So I'm going to help you guys out here. Here's the middle of that page. To learn what it means to be a well-designed experiment, let's start with a bad one. My man, Mr. Luckhow's class, wants to investigate if caffeine affects the pulse rate. So one of his students proposes the following plan. Sure, blame it on the kid. See what I mean? That's what kind of people we're dealing with here. Have each student measure his or her initial pulse rate. Give each student 12 ounces of pop. Wait for 15 minutes. Have each student measure his or her final pulse rate. And then compare the initial and the final pulse rates. What's wrong with that? The control group, there wasn't a control group, sorry about that. They had everybody go through the same thing, so you're not really comparing anything. The control group doesn't get caffeine, but the treatment group does. That's what we should do. The control group gives us, again, it gives us something to compare to. Okay, that's the idea there. Let's go to the next page.